Hello all, welcome to Vishnu's lectures. So in today's class, we are going to discuss how to write binary for negative numbers, what is ones complement and twos complement, what are identifiers, what are keywords, what is type modifiers, and about data types. So first we will discuss how to write binary for negative numbers. That is our task. See, how to write binary for negative number. We have to follow some steps to write a binary for negative number. What is step 1? Write the binary of a number in positive first. Means if any number given, consider negative number minus 50. You have to write binary for minus 50. So what you have to do? First write binary for plus 50, means positive 50. That is step 1. Step 2 is 2's complement. After writing the binary for positive, like positive 50, then you have to do the 2's complement for that positive 50 ka binary. That is step 2. So only 2 steps. How to write binary for negative number means just having only 2 steps, right? But what is 2's complement first? See here, what is 2's complement means 1's complement plus adding 1. That is called 2's complement. But what is 1's complement? 1's complement means replacing zeros with ones and ones with zeros in a binary representation. What is 1's complement? Replacing zeros with ones and ones with zeros. Okay, and this is very important formula. Complement of x equal to minus of x plus 1. Example, complement of 5 equal to minus 6. This we'll discuss later. Okay. Now, we'll write a binary for minus 50 now. See. Listen. How to write binary for minus 50. What is step 1? To write binary for negative number, what is step 1? You know how to write binary for positive numbers, but here we have to write binary for negative numbers. What is step 1? Step 1 is write binary for in positive format. So you have to write binary for 50 first. How to write binary for 50 positive number? We already discussed in last class, like 1, 2, 4, 8, 16, 32, 64. So what is the nearest number to 50? 32. How much left? 18 left. So nearest number to 18 is 16. How much left? 2 left. 2. Remaining all are zeros. So remaining all are zeros. So now step 1 completed. What is step 2? Step 2 is how to do the 2's complement. What is 2's complement? 1's complement plus 1 is nothing but 2's complement. So you have to do the 1's complement to this binary. What is 1's complement? What is 1's complement? Replacing ones as zeros, zeros as ones. That is treated as 1's complement. See, 1, 0, 1, 1, 0, 0, 1, 1, 1, 1. What I am doing here? Simply making zeros as ones, ones as zeros. See here. This is treated as 1's complement. Then what is 2's complement? After 1's complement, just add 1 to the result. This is treated as 2's complement now. So 1 plus 1. What is 1 plus 1? 2. 2 means 1, 0. This is 2. 2 ka binary. So what is 1 plus 1? 2. 2 means 1, 0. You have to write it in binary format only. You should not write directly 2 here. 2 means 1, 0. So 1 plus 1, 2. 2 means 0, 1, 0, 0. You have to write 1 carry forward. Like this, you have to write 1, 0, which is 2. Okay. Now 0 plus 1, 1. Remaining take as it is 1, 1, 0, 0. All are ones. Now this is minus 50 ka binary. Getting my point? Let's write one more example. Let's take Let's take one more example here. Mm, let's take 65, minus 65 ka binary. How to write minus 65 ka binary? What is step one? Step one is first write binary for positive number. Means you have to write binary for 65. How to write 1, 2, 4, 8, 16, 32, 64, 128 and all. Sir, how long I have to write the binary? See here, minus 65 is integer. Integer means 4 bytes. 4 bytes means 1 byte equal to 8 bits. 4 byte equal to 32 bits. Here you have to imagine 32 bits are there. Okay. So what is the nearest number to 65? So first you have to write positive number binary. So what is the nearest number to 65? 64. So make it 1 here. And how much left? 1 left. So make it 1 here. Remaining all are zeros. So remaining all are zeros. Total, how many bits are there here? Total 32 bits are there. In total 32 bits, 2 bits are ones and 30 bits are zeros because it is integer. Now what we have to do? Step 1 is done. Step 2 is 2's complement. What is 2's complement? 1's complement plus adding 1. 1's complement plus adding 1. So first you have to do the 1's complement. How to do the 1's complement? Make zeros as ones, ones as zeros. That is treated as 1's complement. See here, 0, 1, 1, 1, 1, 1, 0. Remaining all are ones. So 1's complement is done. Now what you have to do? Add 1. Adding 1. 0 plus 1. 0 plus 1 is 1 only. Write 1. So next take as it is binary. 1, 1, 1, 1, 1, 0. Remaining all are ones. Now this binary is minus 65 ka binary. Getting my point? So I hope you are clear with how to write binary for negative number and what is 1's complement and what is 2's complement. 1's complement is nothing but replacing ones as zeros, zeros as ones. That's it. That is 1's complement. What is 2's complement? 1's complement plus 1 is nothing but 2's complement. So how to write negative number binary means first you have to write the positive number binary, then do the 2's complement, which is nothing but 1's complement plus adding 1. I hope clear this much. And next what we have to discuss, what are identifiers and keywords? What is identifier? So what are identifiers means? These are the names that we are using in our programming. Simply you can say these are the names that we are using in our programming. Example, variable names and name of variables and name of functions. Name of variables and name of functions. Okay, see here. And a very important point is identifiers must and should be declared. Identifiers must and should. So we have to declare must and should be declared. So we have to declare the identifiers. Why we have to declare the identifiers? Because identifiers are identifiers are unknown to the compiler. Because identifiers are unknown to the compiler. Example, a equal to 5. Here a is a variable. A is a variable. So this is error, you know that, because you have to write int a equal to 5. You have to declare this identifier. Here a is an identifier, because whenever you declared int a equal to 5, then only compiler knows about this a. Okay, this a is belongs to integer data type. Otherwise, meaningless. Getting my point? So this is treated as identifiers. Identifiers are unknown to the compiler, so we need to declare it first. And similarly, function name, if I'm writing some definition, sum of some function, this sum function definition. So this sum, sum, is a name of the function. This is also identifier. So you have to declare this sum function, like I'm taking sum function. It is taking two inputs and it is returning integer data. So this is treated as sum function declaration. So these are the identifiers. So identifiers are unknown to the compiler. Example for identifiers are variables and function names. So these identifiers should be must and should be declared, because identifiers are not known to the compiler. Getting my point? And one more point here, why we are treating variable name as a variable? What is the meaning of variable? Variable means changeable. Variable means changeable. Varying. Varying means changing. So variable means changeable. We can change the variable. That's why the variable name is variable, or modifiable. That's why the name of the variable is treated as variable. Variable means we can change this a at any time. Like if I increment plus plus a, so a value become 6. Getting my point? This is the meaning of identifiers. Next, keywords. What are keywords? This is opposite to the identifiers actually. Means identifiers are not known to the compiler, but keywords are known to the compiler. Keywords means these are the words which are already known to the compiler, which are already known to the compiler. So these are the keywords. Example, all data types, int, char, float, double, and all control statements, if, go to, while, for, struct, all, etc. So in C language, we have 32 keywords total. Just you can Google it, you will get 32 keywords list. So what is keywords means? The words which are already known to the compiler. Getting my point? You no need to declare the keywords. These are already known to the compiler. If you use int, char, float, double, compiler is not going to confuse about it, because compiler already knows about these keywords. I hope clear about identifiers and keywords. Okay, see here. So identifiers, keywords. Next, type modifiers. type modifiers. So what are type modifiers? Type modifiers are the modifiers. Type modifiers are the modifiers which modifies the properties of data type. Which modifies the which modifies properties of data types of data type. Example, what are type modifiers? Example, signed, unsigned, short, long, long, long or long, long, signed, unsigned, short, long, long, long. These are some examples of type modifiers. Sir, how it modifies the properties of data type? Consider here, if I write directly int x, how many bytes allocated for x? How many bytes allocated for x in 64-bit compiler? 4 bytes. Just if I add before this long int x, these are the type modifiers. Now, for x, now it may allocates 8 bytes because this long is a type modifier. It modify the properties of integer data type. Now, because of I'm adding long, the properties changed. Previously, it is 4 bytes. Now it is 8 bytes. So these type modifiers are modifying the properties of data type. Will you agree or not? In upcoming classes, you come to know clearly about this type modifiers. But this much clear or not as of now? Okay. Okay. These are the type modifiers. And you should know what is the difference between signed and unsigned. Anybody knows what is the difference between signed and unsigned? Anybody? Signed means it accepts only both positive and negative. Signed means, just remember, signed means it accepts both positive and negative. Unsigned means only positive. And a very, very important point, all the data types, all the data types, all the data types by default treated as signed. So all the data types by default treated as signed. Very important point. Remember these points. Signed means both positive and negative. Unsigned means only positive. It will accept only positive. All the data types by default treated as signed. Okay. Okay. This much content is enough for to start our data types concept. Okay. If anything required further, we'll discuss. No problem. Next. First, we are going to discuss about character data type. So size of character data type is 1 byte. 1 byte equal to 8 bits. So if you count 8 bits maximum value 1 plus 2 plus 4 plus 8 plus 16 plus 32 plus 64 plus 128. So it is equal to 255. So character can able to store from 0 to 255. So total how many values? 256 values. So 1 byte ka capacity is 256. including 0, total 256 values it can store from 0 to 255. So if you observe, this is only positive. Okay. So total 256 values. If you want to store negative also, then it is treated as signed. Then what is signed range? So 256 divided by 2 means half positive values, half negative values, which is 128. 128 positive values, 128 negative values. What are the 128 positive values? 128 positive values are 0 to 127. These are 128 positive values. What are 128 negative values? Minus 128 to minus 1. If you combinedly write it, then minus what is signed character ka values means. Signed means I already told both positive and negative. So the range should be like minus 128 to plus 127. I'm writing clearly here. Signed character range. Signed character range. Signed character range. What is signed character range? Signed character range is from minus 128 to plus 127. Similarly, unsigned character range. Unsigned character range. So unsigned character range is from 0 to 255. And observe here in this binary, this first position is treated as LSB. Lower significant bit. This bit is treated as MSB. Most significant bit. LSB means lowest significant bit, most significant bit. And this bit is also treated as sign bit. This bit is also treated as sign bit. What is the meaning of sign bit? Means this MSB bit, this sign bit will decide the data will be positive or negative. If the sign bit is 1, simply if sign bit is 1, if sign bit is 1, then it is treated as negative data. Very important point. If sign bit is 0, if sign bit is 0, then it is treated as positive data. Okay. See here. This is the range for signed character flowchart. Minus 128 to plus 127. This is the range. This is from 0 to 255. Okay. We'll take some examples here. For suppose I'm writing a program. Void main function. Char x equal to 50. I want to ask you one question here actually. Whenever I wrote char x equal to 50 means in x, 50 going to be stored or 50 binary going to be stored? First of all, tell me how many bytes allocated for x. Which data type? That depends on which data type the x is. X is character data type. So I already told you the size of character is 1 byte. So how many bytes allocated for x means 1 byte memory allocated. So in this 1 byte memory, who is going to be stored? We are thinking 50 is going to be stored. But actually 50 binary is going to be stored, not 50. In the memory, values are not going to be stored. Its binary equivalent is going to be stored. This point is important. Whenever you are writing any like x equal to 10, x equal to 50, like that, you have to imagine that, okay, in the variable, its binary equivalent is going to be stored, not 50. This point is important, first of all. Getting my point? Okay. Now tell me. I'm writing some program here. Sorry, not int, character. Char z equal to 20. Now tell me, I'm asking some questions here. Z belongs to which data type? Very easy, character data type. Okay. How many bytes allocated for Z? How many bytes? 1 byte, because it belongs to character data type. Very good. Next, this char belongs to signed or unsigned. Sorry, you didn't mention it is signed or unsigned. But I already told you that if you are not mentioning signed or unsigned, by default it is treated as signed only. No need to mention. Getting my point? By default it is treated as signed. Signed character, even though if you forget to mention. So now this Z belongs to first flowchart or second flowchart? Definitely first flowchart. So now Z can able to store all the values which are available in the first flowchart, as it is a signed character. Getting my point? So I'm storing 20 into Z. Now tell me, 20 able to store in Z or not? So Z belongs to signed character range. 20 is available in this range. Definitely available. Getting my point? Somewhere 20 is available here. So Z can able to store 20 or not? Yes. So if I print printf percentage d comma Z, then what is the output going to be printed? 20 only printed. Getting my point? Now see here, one more example. Char ch equal to 127. Printf percentage d comma ch. First of all, tell me ch belongs to which data type? Character data type. How many bytes allocated for ch? 1 byte. This ch belongs to signed or unsigned. Not mentioning anything means by default it is signed. So 127 existing in signed range or not? See here. 127 is existing or not? Yes. So Z can able to store 127 or not? CH can able to store 127 or not? Obviously it will store 127. So it will print answer as 127. But if I write like this, void main function char ch equal to 130, printf percentage d comma ch, printing ch. So now tell me, ch belongs to signed character or unsigned character? By default it is signed. So in signed, is 130 existing in this range? See the flowchart. 130 is not existing, plus 130 is not existing. After 127, who is coming? Actually, 1 plus 126 plus 127. After who has to come? Plus 128, but 128 is not coming. In place of plus 128, Who came here? In place of plus 128, who came here? Minus 128. Next, in place of plus 129, who came here? Minus 127. In place of plus 130, who replaced 130 place? Minus 126. So, who replaced plus 130 place here? Minus 126. So, if you print 130, CH value is not going to print 130. Who replaced 130 place here? Minus 126. So, the answer will print here as minus 126. Getting my point? Sir, you are taken here 130. This is very near. What if I take 150? If I take 150, then you have to count 130, 131, 132, 133, 134, 135, 136, 137 up to 150. So who replaced 150 number, that you have to consider, but it will take some time. So that's why directly you have to use the formula. If the given value, see here, if the given value is not in the range, see 130 is not in the range, then you have to apply the formula taken value minus total values. How many total values in the chart? 256. What is the taken value here? 130. So if you do this calculation, 130 minus 256, then printing, it will get minus 126. Getting my point? Yeah. Similarly, if I take char ch equal to 120, then what is the answer going to be printed? Printf percentage d comma ch. Is it necessary to apply this formula taken value minus total value here in this case? Not required, because 120 is within the range only. So output will be printed 120 successfully. When you have to apply this formula? When the given value is not in the range. I hope you are clear with this. And next, see here. Let's take one more example. Int main function. This time I'm mentioning explicitly unsigned char z equal to 150. Now tell me, z belongs to which data type? Z is a variable, belongs to unsigned character. Now this z can able to store how many values? 0 to 255. Unsigned means this belongs to unsigned flowchart. So 150 existing or not? Yes, existing. So if I print printf, pf means just consider printf. Printf percentage d comma z, then it will print simply 150. What if I take one more example? Let's take int main function. Int main function unsigned char k equal to 250. I'm taking. Is 250 existing in unsigned character range or not? Yes. So what is the range? 0 to 255. So 250 is existing. So k can successfully store this 250, and whenever you are printing k value is going to be printed as 250 only. Getting my point? What if I take, let's take int main function unsigned char y equal to 256. Printf percentage d comma 256. Sorry, percentage d comma y. Is 256 existing in unsigned character range? Not existing. Who replaced 256 place? See the flowchart. Who replaced 256 place after 255? Who has to come? 256 has to come. Who replaced 256 place? 0. So in place of 256, who is there in the chart? 0. So if you print this y value 256, the output should be printed as 0 only. Getting my point? Or you can directly, if the taken value is not within the range, then apply the formula taken value minus total values. What is taken value here? Taken value is 256 minus total values in the chart 256, which is 0. Getting my point? Yes or no? In case if I taken 258, then in place of 256, if I take 258, is 258 existing in this range? No. Who replaced 258 place? 256 is 0, 257 is 1, 258 is 2. So who will print 258 if I print 258? Y value consider now 258. Now who will print? 2 will print. How to do it? Simply taken value minus total values. This type of snippets may ask in your exams. If you go to any competitive exam, they will give like this: unsigned char y equal to 258, print y value. What you will do if you don't know this concept? Simply you are going to print 258 only, but do this taken value minus total values. Taken value is 258 minus total values are 256, which is going to be print 2. Okay. But interview point of view, you should not explain the formula taken value minus total value like that. This is just for exam purpose. What is the actual meaning? See here, if interviewer asks you this question, let's take the question is like this: unsigned char ch equal to 300, printf percentage d comma ch. Now, what do you have to think? First, you have to know that this belongs to character data type, that is unsigned character. So, unsigned character range is 0 to 255. So, the given value, taken value is not within the range. Then, you have to apply the formula. What is the formula? Taken value minus total value. Taken value is 300 minus total values are 256. Then, you will get 44. This you should not explain in interview. How you have to explain this interview means you can explain this. This is actual meaning. First 300. So first write the 300 binary. How to write 300 binary? 1, 2, 4, 8, 16, 32, 64, 128, 256, 512. Nearest number 256. How much left? 44 left. 32 plus 32 plus how much you want? 44 means 32 plus 16, 48. 32 plus 8 plus 4. Remaining all are zeros. Now this is binary for 300. Getting my point? Now CH has to store this 300 binary because CH is 300. I already told that CH belongs to which data type? Unsigned character. Unsigned or signed character, whatever it is, how many bytes allocated for character? Only 1 byte. 1 byte equal to how many bits? 8 bits. So if you are trying to store 300, 300 binary is this one. So this is exceeding 1 byte or not? Means it is more than 8 bits or not? Count here: 1, 2, 3, 4, 5, 6, 7, 8, 9. If you are trying to store 300, for writing 300 binary, it will take 9 bits, but ch can able to store only 1 byte, which is 8 bits. So this rightmost 8 bits only it will going to store. 1 2 3 4 5 6 7 8. This much only the ch will store. Even if you try to store 300, it will fetch only 1 byte. So this 1 byte ka value is 00101100. If you try to store 300 into ch, that ch will store only this 8 bits. Because why sir only 8 bits? Because ch is 1 byte. So that's why this 8 bits only going to be stored in ch. What is the value for this 8 bits? 1, 2, 4, 8, 16, 32. 64, 128. 32 plus 8, 40. 40 plus 4, 44. That's why it will get output as 44. This you have to explain in interview. Getting my point? Okay, just do the same, whatever we discuss, just do it practically. va space data1 dot c hash include just a minute, hash include stdio.h into main function. Let's take char ch equal to 127. Now tell me, this ch belongs to which data type? Character data type. Signed or unsigned? Signed. What is the range for signed character? Minus 128 to plus 127. Means 127 existing or not existing? 127 is existing. So ch can able to store 127. That's why you can print 127 here. Comma ch. Getting my point? See here. cc space data1 dot c data, okay, spelling mistake. Hash include stdio.h hash include stdio.h. Sorry, here one more dot is there. So here 127 existing means 127 will print simply. Dot slash a dot out. So output printed as 127. What if I take minus 128 here? Is 128 existing in signed character? Existing or not? 128 not existing. It is 127, 0 to 127. So who replaced 128 place? 128 will be replaced by minus 128. So in place of 128, minus 128 will be printed. Minus 128 is the answer here. If I take 130, then who replaced 130 place? This we already did. Minus 126. So if I take, so this is signed now. So we'll take unsigned. unsigned character ch equal to 255 or 130 if I take. Is 130 existing in unsigned? Yes, because unsigned range is only positive, which is 0 to 255. So 130 means existing, 130 only printed. See, existing means 130 only printed. Consider if I take 255 here. 255. Is 255 existing in unsigned character range or not? Existing. So that is only printed. 255 only printed. If I take 256, is 256 existing in unsigned character range? No. Who replaced 256 plus? If not existing, simply use formula taken value minus total values. 256 minus 256, which is 0. Yes or no? In 256 place, who is there? 0 is there. So 0 is going to be printed. So it will throw warning. 256 is exceeding the range. So 0 printed. Getting my point? And similarly, I explained about 300. So if I take 300, then 300 not existing, only character will fetch only 1 byte. So in 300 binary, only 1 byte if you fetch, what is the output? I already explained this. You will get 44 as an output. Okay, now I hope you are clear about this. In upcoming classes, we'll discuss remaining data types, short integer and all. Okay, and very interesting snippets we will uh, do at runtime. Okay, I hope you are clear. Thank you.